homes are making us sick and they're costing us the earth. Entire sections of our society are locked out, buckling under debt burdens that become unmanageable, and a narrow definition of affordability appears to deliver lower quality outcomes rather than designing to achieve high performance quality over the life cycle. Even if we stretch to get on the ladder, crippling running costs, which in a 50-year life cycle can be up to 80% of the total cost of ownership, make this a dubious long-term proposition.
And this is just about to explode. So in the next 40 to 50 years, if all the trends hold true, then we have to double the total amount of urban development currently on the surface of the planet. And I should pause there for about 30 seconds, but we haven't got time because that's just mind-blowing. So that development is taking place, largely as self-built cities, but it's done by people who don't have the tools to do it well. And the results are slums and favelas, and we're not necessarily insulated from that. So the current approaches are not going to cut it as a total solution. So I would suggest that the way we're approaching things just isn't going to work. The results right now are heartbreaking, actually, of our failure to meet the needs on the ground. So we need a thought shift. We need to think about a different way of doing this. So there is a huge untapped resource, amount of energy within our communities. If we give them the right tools, what can we achieve? We think we can actually find a solution right here. So WikiHouse is about two things. The first major aspect of it is about high-performance buildings that are affordable, so they're available to everyone. So this is the simple part in a way. So this is warm, dry, safe, healthy, attractive, sustainable homes. How hard could this be? Well,
So after the Christchurch earthquakes, we needed some solutions. We got together and we decided that if we were going to spend years rebuilding, that why don't we do it properly? We were looking for something that wasn't just incremental, something that would actually move the whole debate into new territory and revolutionise the way we do things. So we began by conducting a world search of systems, starting with shipping containers, which was where everyone started in Christchurch, but then quickly moving beyond that to find something that ticked all the boxes, a complete rethink of the way that we actually not just build our buildings, but build our communities and our urban infrastructure around them. So we're looking for not just a prefab solution, but a community-driven development solution. We found WikiHouse as a global open project in its early infancy and joined up. We're a group of experts and users with a shared vision are creating common solutions, but in a localised manner. So it's a one size fits many, or many sizes fit one. Our volunteer efforts through joining this collaboration have now put New Zealand on the map as one of the leading, if not in many ways the leading protagonists of this project.
So the second aspect of WikiHouse, and we think this is the even more the important aspect, is what happens if we could create a model where our communities themselves can deliver the environment they've always needed. So we change the entire procurement model, or we at least provide an additional complementary one. So this is about a model for assisted delivery of our built environment. So ordinary people are able to design, manufacture and assemble high-performance living environments. So, blah, 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 all these things that we want. How do we actually do it? So, how does WikiHouse work? So, I want you to imagine a scenario. I'm going to get you to imagine this young girl. She's called Susan. She's 9 years old, and she lives in a family in need, actually, in terms of their built environment. She observes her parents under enormous stress. We can imagine either their house has been affected by an extreme weather event, by an earthquake, so there's loads of earthquake repairs still waiting. Where does that happen? Or they just can't afford to maintain the house, and it doesn't work anyway. It's cold and damp, and they pay a fortune for it. So she thinks, can I do anything about this? And she does a bit of Googling when she gets to school, and she finds this library of open source housing designs and a community of experts who can help her adapt a design for her particular needs. And then when she's got the design to where she wants it, there's a magic second stage, really interesting. It says print this house. And what comes out the other end is sheets of printable parts for a house. Amazing. So she downloads it onto a pen drive and she rushes home and she has a quick chat with Grandma. She says, Carl, I think I'm onto something here. You know, I've got a design for what we need on you know, from school. And Grandma says, Carl, you've got to be kidding. She says, no, you know, just run along with me. Give me a little bit of slack here. Let's find somewhere we can make the house, you know. So they do a little bit more Googling and they find a local manufacturing facility that can manufacture this house. Now, if this looks like your garage, that's no accident. So we've already proved that out of a facility of this sort of size, you can produce an entire, full-scale, high-performance urban environment. So she takes the designs along here, and what comes out the other end is the parts. You pack them in the back of the community van. This is our proof of concept in the back of Delta community van. These are human-sized pieces, so no heavy plant on site. Anyone from 8 to 80 can get involved in assembling the building. So Susan says to her parents, okay, you guys, you need a holiday. Take a weekend off. And she calls all her friends around, and Grandma calls her friends around. And all they need to put the whole house together is a mallet. No screws, no fixings, no glue. And that's where the fun really begins. So they invite their friends around. So this is a social activity. So we're building communities by making buildings. And then this is not new technology. So this is the way we used to build. So this is a blend of ancient wisdom and modern technology. Some of the R&D in this building is 900 to 2,000 years old. So this is the way we used to do things. We're not reinventing the wheel. We're just bringing back what was the best things that we used to do in the past. And this is about building confidence. So you imagine when that building is built, and the parents come back after a long weekend and, holy moly, there's like an entire high-performance building, and my child and Grandma built it over the weekend with their friends, you know. They're in tears, you know. And imagine the confidence then. So all those people in that community walking past that every single day thinking, if we can do this, what else can we do? So this is about also building enormous a sense of ownership within that built environment as well.
So have we done this? Well, we're on the way. We went to the Festival of Transitional Architecture down in Christchurch last year with our prototype model, and here's a short video of what we did. So we sent out the call on our meetup group for 12 ordinary people to help us assemble this building. We required that they had no skills, no building experience and no training. They hadn't seen the system before, so we laid it out for them on the floor. We gave them a quick briefing, armed them with rubber mallets, and then we set them loose. And what happened really blew us away, because they split into 3 teams of 4, self-organised, and started assembling this building in quick time with minimal guidance from us, just a little helping hand here and there. So just, if you watch this happened in under 2 hours.
So what you see emerging here is a slice through what would be a larger structure. And I'll explain a little bit about why it's shaped the way it's shaped. One important point in these closing credits is there's a few people who've made this project possible. Our sponsors, in particular Health 2000, Fab Lab in Wellington, and Matter Machine and Health have been the key people who've made the project happen so far. So what you saw emerging there, in many ways, was visual expression of design ingenuity. So with the system we're designing, you can design any building shape you want without a cost penalty related to custom design. The front wall in the proof of concept is taller to take advantage of the north-facing passive solar gain, the ideal angle for photovoltaic on the roof, a shallower angle for rainwater harvesting, and a lower wall on the sunless side to reduce exposure to the cold side of the building. an interesting point here. You don't need a huge amount of thermal mass in your footing if you've got a really, really high performance envelope. The other thing, one last point I'll make on that one is that we're spanning, that's clear spanning over 5 metres there, using engineered timber, a fantastic resource that we've got here in New Zealand, and that's standard stock size sheet material, so it's nothing special, no special tech in terms of the materials that go into this. And then what you've got is a very high performance chassis onto which you can bolt a very high performance skin to assure optimum temperature and humidity and plenty of light all year round. And then we're also testing other aspects of the project. This is our green roof. It's looking a little bit sad for itself, but then it's just been through a 1 in 100 year storm, amongst other things. So the parts of the building are coming together. And then what does the final result look like? So whatever you want. So the system doesn't dictate the way the final building comes out. Now all the teams globally are around about the same sort of stage, just starting to produce the first fully finished proof of concepts and prototype buildings. This one's in Utah. They actually lived in this one for a short while. So why hasn't it been done before? Because it's tough. And so one of the first people we went to right at the very beginning of this project was Larry Sasser at MIT, who did a precursor system to this. And he said to me, no matter how hard you think this is to do, it's harder than you think. So then why is it possible to do it now? Firstly, on the left, this new collaborative economy and open source project. So finally, whole lots of people all over the place, small groups of people can pool their expertise and share that openly. So it's openly licensed. So everything we learn is fed back into that community. Huge revolution and the communications to support it. And then on the other side, this distributed production. So that the machine you saw in that workshop is called a CNC router. It's 1950s technology, was when it was invented. Google currently working on a project where they hope a machine might come out the door eventually for about $500 US. So that's mind-blowing stuff. So this distributed manufacturing changes everything. You can finally have a meaningful employment out on the East Cape. The young people don't need to leave there to have modern skills. You don't need to bring in 35,000 people to do the Christchurch rebuild and then wonder how you're going to build housings to build the people who are going to build the house anyway. So that changes everything. And then so many advantages of open source, I could go on and on. But basically some of those are that as a small startup in Christchurch, we actually have a global team of experts working 24/7 on this project. So many other advantages, but we haven't got a lot of time here. Has it been done before? Yes. Okay, so a good example, just one amongst these, so Spark Fund alone, $75 million turnover a couple of years back now actually, 140 employees. So you can actually do profitable businesses even though you're giving away all your ideas.
So a bit more about us and what we're about. So we're a social enterprise, which means social enterprise we formed is called Spacecraft Systems, and that's developing the WikiHouse platform in New Zealand under the WikiHouse NZ lab. As a social enterprise, we use business tools to create economic, social and environmental value, and each of these three core values we hold in balance, so no one of those values can be traded off against each other. Out of this comes a system of creating a system of adaptable design that empowers people to create their own protective environments. What we've then done is we've mapped our core values against 4 areas of sustainability: economic, social, environmental and regulatory, to create a matrix of value aspirations that drives our decision making. So whenever we need to make a decision within our enterprise, we assess it against, does it stack up with all these values? And this gives us an objective tool for ensuring that those values are actually carried through into the operational decisions of the enterprise. We also co-create these values with our team in an ongoing business development program, and we're actually pushing that out to Lumio as we speak now with, because you can actually, with a platform such as Lumio, which is an online decision-making platform, it facilitates much speedier decision makings where people are more involved in the process. So this is another breakthrough in the way that we do things that we weren't able to do before, so delivering greater beneficial outcomes. So a bit more about adaptable design. Build what you want when you need, change it when you want. This is the third wave of the Industrial Revolution where digital fabrication can create a web-based interface that allows non-technical users to be part of adapting these design. It also permits new financing models, and we've heard a lot about financing today. This is our model. You actually build what you want when you need it. You can pay it off within 5 to 7 years on a living wage, and then you have no rent, no mortgage, no running costs, and you're not tied to the land because you can move your building in the back of a van as easily as you move your contents. So it changes the equation dramatically around home ownership. Then you can add on as you grow. All that area under the graph between the red and the green is saved interest.
So what we're talking about here is a model that goes way beyond ordinary models of consultation. So this is one of a workshop with another team, Viva, who provided a tool so that ordinary people can be grouped together to do their own development. And in this model, then it never comes out of their hands. So it's not that it takes it out of the hands of experts, but it never comes out of their hands, goes somewhere else and comes back down again. And then the end results, we think, are communities truly worth living in. So this is the Earth Song example on the edge of Auckland. So you've got examples right on your doorstep. And if we don't get that right, how can we talk about quality in our communities if we can't do that? Resilience. So we're talking about true resilience here, building true resilience into our communities. So imagine some major event, extreme weather event or earthquake. There's very little damage anyway because the buildings are extremely strong, but all the damage there is can be repaired rapidly, economically, and within the community itself in less time than it takes EQC to come around and do a so-called rapid assessment.
So then we talk about a protective environment that protects people, their interests and the environment. Buildings that generate that have no running costs, they can actually generate an income by sitting in the sun. I probably don't need to mention the ECA audit that found insulation installations to be severely lacking in New Zealand. But what this does is it allows us to get better measures of affordability and true value in projects by feeding in the other important aspects, socially and environmentally, that go alongside the economic drivers. Creating an entire high-performance package where the sum is greater than its parts. So longer term, I just ask you to imagine a building designed and constructed to function as elegantly and efficiently as a flower. A building informed by its bioregion's characteristics and that generates all of its own energy with renewable resources. Imagine a city block or a college campus sharing resources from building to building, growing food and functioning without dependence on fossil fuel transportation. And imagine true sustainability in our homes, workplaces, neighbourhoods and villages, towns and cities. Socially just, culturally rich and ecologically restorative.
We probably should finish there because I'm aware we're over time. So there's a few more slides which we can kind of perhaps throw open during or just flick through as we go through to the questions. So the last slides really cover what the next stage of the project is, small semi-autonomous unit of about...
So I'll flick through them quickly. So and I invite debate around in the questions or anything. So this is what we do. We get our logs and our forests, and we sequester carbon, which is great, but then we ship it off overseas. There's no value add in that. We buy it back. We're creating technology and industry all around New Zealand. That's been talked about today, where we can value add on the chain to create high-performance engineered timber products. These engineered timber products can then be turned using digital fabrication and manufacturing into high-performance building kits. A model of self-provided housing or assisted self-delivery which allows ordinary people to engage in the process. And we've developed what we call an open value chain, which allows a true engagement model of facilitators as spacecraft systems as a social enterprise helps facilitate a project delivery with a community of users or group and whatever third-party expertise you need to bring in, but keeping people engaged all the way throughout that process. This is our next phase of development, which is the backyard model. So we're talking about, we're YIMBYs, yes, in my backyard. We want people to be building these. So we talked earlier about the model of splitting a house. So you see that house at the front, you can split that in two and put a backyard in the back, and then you've got 3 families or 3 dwellings on a site, and they could be shared people who want to share communal living in that sense, but each retain their own separate identity and title, and however you work out the logistics of that is up to the people involved in a lot of ways. That provides another model of ownership for densifying the land use. Moving on further from that is the idea of a self-built community that has its neighbourhood studio, which is your CNC manufacturing facility, providing a distributed point of manufacture throughout the system. So in terms of the slideshow, we could go on, but that's just the beginning. Thank you.
There's a huge amount of ideas and a huge amount of thinking there, guys. Does anybody have, because I've got about 1 million of them, does anybody have a question for Danny or Martin?
Just wondering how you incorporate your additional other systems.
Sure. So what we're looking at is there's a lot of systems. There's another one I found the other day, Cake Elite, is a plug-and-play plumbing systems. Schneider make a plug-and-play electrical system. So these are systems that anyone can install, but they just need a Sparky to sign off at the end. The system's pre-approved. So the whole idea of the systems we're developing throughout the whole building is about either getting multi-proof solutions through for the wider structural and envelope design, or using whatever approved products are on the market. I guess I've heard today about the challenges getting some products approved in quick time, and I think that's something as a collective group we can all sort of push for, is to allow, because there's so many great products out there. I mean, someone said earlier today, all the pieces are there just waiting to be assembled. So what we're trying to create is a platform for all these pieces to be put together in a way that's far more accessible to the ordinary person.
Okay, thank you very much, guys. A hand for Martin,
Oh,
Martin Ben, please.